Alright. What's up, y'all? Gonna continue more of the same interview prep. I kind of like losing my voice, so I don't know how much talking I'm gonna be able to do. Or at least like talking that you'll be able to understand. But yeah, more of the same. More of the same. I want to get better at this leetcode thing. The thing that's like kind of annoying me is I can't like I went back over the task scheduler thing that we did the other day, and I tried to rack my head around like fully remembering the implementation before looking at it, and I like kind of didn't, which is a little bit scary because it's like, why am I just wasting time if I don't remember the things that helped? Because like I'm at the point in leetcode where it's like I've seen the algorithms, most of it. I've seen the data structures. Like, none of it is new to me. I know topological sort. I know what a heap is. I know when to use a priority queue. Like, I know these things. So, yeah. I don't know. It's like a weird feeling where it's like, I feel simultaneously like prepared and also like I'm stagnant. Because it's like, this isn't the first time I'm seeing a deck used with a heap. But I don't know. Anyways, I'm gonna try to do these two. This one's the daily, but this one is the last one that was asked like past 30 days. I can always like go back out 6 months and just get more. So I'll probably just do that. But yeah, I don't know. We shall see. I'm probably gonna try to do like 2 hours ish. This one seems I'm doing that one right now. Did that one, so this one. I've done this already? Interesting. Okay. Let's see if there's a leetcode one for this. No. Alright, so we'll just watch a video on that. That sucks. Or maybe okay. Let's start with this. The score of an array is defined as the product of its sum and its length. For example, a score of 1, 2, 3, 4, 5 is that times its length. Okay. Given a positive integer array nums and an integer k, return the number of non-empty sum arrays. And a subarray is contiguous. Okay. So this kind of feels knapsacky, where it's like at each point we have a choice, and the choice is simply first we ask ourselves, if we have our current subarray and we add this number to it, are we going to be greater than k? If we are, then we automatically just have to give up. But if we can, then we need to decide, is it optimal to like take it, Or is it optimal to skip it and start a new subarray? The thing I don't fully understand is like, so like for this, 2, 1, 4, 3, 5, and 2, 1. Oh, interesting. So it's actually not, it's not at the same time. It's like independent of each other. Okay, interesting. So like this, you could have this, you could have this, you could have this, you could have this, or you could have this, but you can't have the three of them. How do we want to represent this then? Is it... It can't be something as simple as like, it can't be something like each array element is like the number of subarrays that it's a part of, because then we'll overcount quite a bit. What we could do instead is something like each array element is like the number, a subarray that like can start there, you know? I think I like that. We might run into some time issues, and my head is already thinking of some pruning that we could probably do, where it's like, you can imagine the case in which we start at 2, and it's like, okay, we start at 2, and we know we can go to 2, 1. So then, it's kind of like sliding window-esque, actually. Feels sliding window-esque. Because it's like we start here, okay, that's 1. We move to 2, 1, okay, so 2 now gets 2. We move to 2, 4, can we do that? No, we can't. So let's move our R back 1, and let's move our L in 1, and now we're at 1. Because it's always guaranteed that that can be less. So I don't actually know if this is this marked as dynamic programming? It seems like, ooh, let's fucking go. Yeah, does seem slightly window-esque. Interesting to why they would want binary search. I like kind of cheated by looking at the tag, but what would you binary search on this? Maybe it's like, what would you binary search on this? So I mean, anyways, naively, that's my implementation. How might this get better? Like, we can't sort them. We could prefix some, but I don't know how much that helps me. It does help me quite a bit, actually, because then you could do R minus L. Huh. Let's talk about the naive one. So naive. I haven't slid a window in so long. Do you make R or L the one that you're like while looping on? I think it's R. Let's compute a prefix sum first. Times n prefix 0 equals or num and nums. We'll just enumerate over this. We can't just fuck it. Dude, I can't type. So let's move this down here. For L, this range, subarray sum is equal to prefix at R minus the prefix at L. While R should start actually L plus 1. F L less than K. This equals 1. I don't know if I love that case being there, but that's okay, because then it's like we're going to start sliding our window. So this is isolated case of an element. Attempt window. Right, now this does go out here. I don't know why I'm forgetting how to do this, which is really annoying. Come on, Aiden, think. So we're looping L. So we just go while our subarray total is still less than K, we'll walk our R. And then, yeah, I think this is fine. Dude, how is that possibly in the buffer? While our r is less than n, we can move that in. If subarray sum greater than or equal to k, break. Else our res will plus equals 1, r will plus equal 1. Do we actually want to break? Or do we want to minus equal 1 from r here? I'm purely thinking for the case of like, so we take our 2. That would be 1, we'd take 2, 1. That's fine. That's still fine. But then we would go here, and this would break. Then our pointer would be at 4. So then we will move 1 in. So our L would be that. And our R is would be 4. It'd be this, which is 7 minus 3, so it's 4. Oh, I'm also forgetting our score. Yeah, because this would be times 1, so that's fine. But here, god damn it, times r minus L plus 1. Or is it just r minus L? What's the length? This is r is 1, 1 minus 0, it's definitely plus 1. Instincts were right there. I'm just trying to think if we ever need to, like when we actually reset the R. Wait, is this like a 2-pointer thing and it should be like while L? No. No, I don't think so. This feels like 2 pointers actually instead of sliding window. But that also just seems wrong. This seems wrong. It feels like it should be 2 pointers. It feels like we should always increment our R and like start anew. Just because I'm really stuck on like this R staying here just seems so wrong to me. But I mean, obviously that kind of fucking cheated. And it's like I saw that it's sliding window. But if it's like 2, 1, 2, 1, 4, like our L is here, R is here, R moves to here, that's invalid. Like I'm saying, like what if it's like 1, 1, 1? That's like, so this is 4, there's 2, so that's actually fine. but then here it would be 5 times 2, which is 10, so it's not fine. So then we would move our L to here. So this would be our L. And our R would be here. But we're just strictly missing this case. So I actually don't understand this. Like in my head it should be this. And I don't fully understand why it's not. So let's just try this. It's probably going to time out. I'm answer 8. How's it 8? So we would contribute 5 from here, so then somehow we're getting 3 in here. So how is that happening? With 1, 0, we have a prefix square of 2. That's definitely just wrong. How's that wrong? Because that's 2. And the prefix score... Because that's a 1. That's 2, 3. Am I stupid? How do you calculate stuff from prefix sums then? Because like this, the sum of this should be 3. Dude, how am I forgetting these basic things? Because the sum should be 3 here. It's like here. Is it L minus 1? Like, okay, so from here to here, the sum would be 8. So this would be our L, this would be our R. Yeah, so it's minus L minus 1. Interesting. Left equals... This is stupid. This just seems so wrong. Fuck, I'm so dog shit at this. Yeah, it's too slow. I don't know how to make this faster though. It's this part that's just like not making sense to me. How do you speed this up? You're supposed to walk with the right one? Am I that fucking stupid? I mean, it makes sense. Like, for this specific problem. It just, like, makes sense that you're supposed to walk with R.
No, but my only, like, the benefit is just that if you talk to me, like, I get like 15 minutes off. Yeah, because this is just like the way I have to say it.
Oh, I'm so not gonna get this job. I don't think we need to curse something, actually. Yeah, it's sliding window. Something that I apparently can't do. This is so stupid. What am I doing? Actually, what am I doing?
Actually, you trying to like come hang out? We're gonna start playing Blover.
That just seems wrong. For I add and enumerate nums, the sum is greater than that, while the sum times... We don't have the sum. Of course. You do that by the amount. Does that even make sense to me? Why is it plus the right minus the left? like in the case that's like 1, 2, 1, 1, 1, and this is our array. Why are you adding 4? I guess because when you walk it, then this is gonna be 3. Like, how does that cover that many ways? Because I thought it'd be like a combinatoric. Alright, thanks, man. We're gonna. I guess the combinations just like take care of themselves as you're going. Like, I'm just thinking about like the individual cases where it's like this element getting added to res. If it's that element getting added to res, I just don't think like it's covered in this. Note that element I forms I minus j plus 1. That's the this is because j plus 1 to I. Okay. Nobody explains it more than just like that's what it is. So what do you actually like? What is it? What are you binary searching here? I just like disagree. Okay, everyone just has the same fucking thing, and nobody has something to help me. No, my mind doesn't work. Oh, am I getting order of operated on? I might be getting order of operated on. God, I'm so fucking stupid. It actually hurts. It actually hurts that I'm this fucking stupid. Oh yeah, no, definitely the first fucking time I've seen this. I'm just on. I guess because it's for every R. Just like so, it just works. It just works. This is the solution. Alrighty. We're given two integers m and n representing a zero index n by n grid. You're also given two 2D integer arrays, guards and walls, where guards at I equals a row I call I, and walls j represent the positions of the ith guard and the jth wall. Okay. Guard can see every cell in the four cardinal directions starting from the position unobstructed. Interesting. Okay. Um, so, like, naively, my brain just wants to go, like, essentially just marking everything. Like, create a new grid that's like, just essentially DFS in one direct, like starting at a guard, just DFS until you see a wall. And then we could do some math. As to like what's blocked and what's not. This doesn't seem that hard. I might like time that exceed what I'm thinking of, but it doesn't seem bad. So essentially, we loop over the array, over the grid. If we encounter a guard, we launch 4 DFSs, one for up, left, right, down. And then the DFS just keeps going in that direction. Does it even have to DFS? That'll probably be easier if it just DFSs. And then just marking that thing is like it's occupied or like guarded. R in range, and no, C in range. Return. A row has to be greater than or equal to. A row has to be less than 1. And our column is 0. Column has to be less than n. And grid R C has to be not equal to wall. So if it's not a valid guard, return
Dude, he was hot as fuck. What the hell? You need it?
This is a heinous way of doing this, but whatever.
Thanksgiving at the earliest is like easily hilarious. I really love crowd. You're probably right. It's just like it's a, no. It's like honestly, it's kind of why I love it.
So if this is a guard, we can start our DFS. Start our DFS on I really hate this. Long encoding like you, I learned by myself. Probably not that long. I don't know. I'm not very good. Pretty dog shit at this. But I mean, we're just stuck with it for a while. Not for the faint of heart, though. So in this first example, we have guard. Oh shit. Wait. What is my logic here? So if we're inbounds, when is it valid to guard? It's valid to guard if we're inbounds. And our thing is not equal to wall. I'm like, this just should be equal to wall. So how is it getting overwritten to guarded? Is my question. Wait, but like, is this actually just like fine? You have 1, 2, 3, 4, 5, 6, 7. Maybe my num guarded is getting fucked up. Should I change this to like num covered? Like, okay, it's valid if you're inbounds. And your thing is not equal to a wall. That just like is right. Grid at RC is, we'll call it guarded. And then we increment our number covered. I guess because we're double counting. Or just like if it's like a 0. Four just seems stupid again. Bro, fuck my life. So like right off the bat, our num covered should be equal to 1, 2, 3, 4, 5, 6. So our thing is 6 and then it's 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's just wrong. It should be 17. But I just don't understand how we're double counting here. Because we only increment this if we've never seen it. Like a wall is our stopping point. So if it's a wall, if this is a wall, then this is false. Then we would return. If we haven't seen this spot yet, cover it. And then keep going. Dude, what the fuck is wrong with this? So 0, 1. How are we getting to 0, 1 though? Like 0, 1 should so clearly be labeled wall. This is fucking WR. Actually, I'm gonna fucking crash out. All this work and it's probably just gonna insta timeout when I submit it. Yeah, it just times out. Bro, I can't write efficient code for my life. When can we prune? I just don't know when you can prune for this. Like, actually. I might fail this interview, guys. I might fail the interview. Is there a smarter way to do this with, like, walls? And just, like, groupings? Would, like, a BFS be better and we just add every guard to the queue? Do we have to traverse everything? Like, is there a way to just not traverse things? I don't know. I'm gonna crash out. Union find. What's up? Okay. We're back. Ugh. I just want to see like a DFS solution. Dude, what the fuck? This is the same thing I did. Like this part just happens here. I guess I don't need this part. I guess this is all wasted. This is just wasted. And I can just change this for... I can just change this up here. Alright, no, I can't do that. I need to take the one that failed. I guess because it's just a bunch of string comparisons. So is that really the slow part? Because I just don't see what else is different here. Like we can call guard a 1 and wall a 2. So this is a 2. And then guarded can just be a 3. I don't know how this times out. Oh, time limit exceeded code, haha. Bro, I'm gonna kill myself. Of course this is a BFS. Literally, of course. I just would have thought you had like the guards to some queue or something. But I guess just like literally, continually, if stating them is also fine. Let ask before I just implement it. Or I should just implement it. I should just implement what I was thinking. Because I wouldn't have done it this way for a BFS. So I would have definitely followed this. That's a 2. type this out, so I'm just going to copy it. Same basic setup. Really just like an underrated annoyance of like how fucking slow my monitor is right now. So what I probably would have done is that like, I guess it doesn't work. Like, this is stupid. I'm literally just re-implementing the same fucking thing. I'm so fucking annoyed. I'm actually so annoyed. I don't even think you need this. I think you can just do this smarter. And it's like num guarded. Wish I could just steal my old just like not equal to 0. is such a stupid. This is so stupid. I'm just doing the same fucking thing. I think this is also gonna time limit exceed now that I'm thinking about it. I'm making like the same, essentially the same stack call. This is x, y is not defined. How do I stop? Stop. Stop. Literally stop. I just want to stop. Alright, submit. Okay, cool. Cool. Alright. Time to get yelled at for being stupid. Haha. Is that real? I actually just like, I just hate my life. Why am I so dog shit at the thing that I should be good at? Ugh. Wait. Was that the fucking problem with mine? This can also be changed, but... Oh my god, it was that. I literally had the right implementation. It was just that fucking. I thought if you just hit another guard, it was fine. You just keep going through them. I can't read. I can't read. I can't read. I'm gonna crash out. I just spent so fucking long on that. My god. Okay. I'm trying to lock back in here. You're given an integer and nums and an integer target. You want to build an expression out of nums by adding one of the following symbols. Well, this is like the actually like the shittiest example. Like, you choose 5 of the same numbers. Do you have to use everything? When did I solve this? Before each integer. Is this just backtracking? Is it just backtracking? It seems like backtracking. Yeah. Yeah. Why'd it go backwards though? Can't you go like the other way? Because like, I mean, this much is obvious. But why do you go backwards? Why do we go backwards? I don't know. I mean, I just like imagine you can do it forwards. Like, FDP. We have it's just like if index 0 or no. If index is equal to so if index is equal to n and curly equals target, index plus 1, and then cur plus nums at index. And this is the negative version. Literally just changes this. Return. Stick an add cache on this. Return dp 0, 0. Yeah, I mean this one was trivial at least. That's cool. When else did I solve this? Back in January? Holy fucking, what was I doing? Hey, I did the same thing I did here. But with a lot more thinking. Okay. At least that one's easy. I'm gonna read through this one. It doesn't have like a formal lead code one, but I'm just gonna read through it. You have a group of people who have been lending money to each other. And now they need to settle out their debts. Given a list of transactions where each interaction tells you who paid, who received, and how much money was transferred. Okay. After all these transactions, some people might owe, while others might owe money attached to a minimum number of new transactions needed. This kind of seems like union find. Because things would just like bubble up. Okay, definitely not a graph. Backtracking? Why? Think about what happens after all the original transactions. Each person has a net balance. They either owe money or they are owed money. The key insight is that we only care about these final balances. Yeah, of course. For example, I don't need an example. And now here's the crucial observation. When we settle debts, we're essentially trying to group people together. The sum of their balances equals 0. Yeah, obviously. Within each group, we can settle all debts with group size -1 transactions. Sure. That's an interesting observation, but it makes sense. For instance, if we have 3 people, person 1 can receive 2 from person 2 and 3 from person 3, settling everything. We optimally partition with non-zero. We use dynamic programming with bitmaps to avoid recalculating. For each subset of people, check if their balances sum to 0. From and to with the cost. Okay, this is just filtering down. Smart people needed to settle debts for the subset of people represented by bitmask I. For each possible subset, we calculate the sum of the balances. Bro, what? This cannot be my intended solution. I just like disagree. It is. Jesus fuck. Okay. For I in range from 1 to 1 shifted over by m amounts, where m is the length of the number of people that we care about. So it's essentially 2. What is the fucking restriction on the number of people here? Just don't get constraints. I'm going to go over each person. And if we shift over by this is so unintuitive. Let's do the lead code contest. I could maybe tomorrow, but I'm gonna get off soon. I'm already fried, no lie. My computer is killing itself right at this moment. Okay, cool. Yeah, I really want my entire fucking system to just lag beyond belief. Christ. For person index, person balance, if the mask what is this doing? I'm really having trouble visualizing this. If so this is all numbers from 1 to 2 to the number of people. And it's just like if we right shift that number. What happens first here actually? Dude, my fucking god, I'm gonna lose my mind. I'm actually gonna lose my mind. Bro, the one time I want an AI answer in my life. Shut the fuck up. So we either shift by 1 or 0? I don't understand this. If they're in the mask? So when would this not run? This is essentially just saying like either you're currently 0 or you're 1 in the mask. Like, this code makes no fucking sense. I really don't fucking understand. No clue. Ending 1. Shift Now, I know what a mask is. The mask is that. Bro, it just fucking lied to me then. The and happens first, and then in here it's saying the and is not happening first. What are you talking about? Like, motherfucker. I'm gonna lose. I'm actually gonna lose my mind. See, this is so extreme. Literally, right above, he told me that we do person index one first, then shift. In this interpretation, we were saying we do a shift first, then check against one. Essentially, like, which interview do you have for Pinterest? I'm gonna lose my mind. Yeah, okay, that makes so much more sense if you wrap this in parentheses. So this is just like calculating all the balance sums. If the balance sum is 0, then the subset can be used. Try splitting this. All the best, man. Appreciate it. Sorry, I'm really kind of I'm in a weird mood right now. A couple problems did not go my way tonight, so I apologize. Try splitting this group into 2 subgroups. Iterate through all non-empty subgroups. Is that needed? It's clever bit manipulation. Iterates through all non-empty. This is a dog shit explanation. This site, this is just terrible. No lie. All of the explanations is just like, this does the intended thing. sure. If I get asked this, I'm not getting the job though. All right, I'm giving up. I'm calling it a day. Yeah, I'm not gonna get this job. Cool.